If you were to guess what they were studying in a science lab deep underground, you'd say worms, right? I said worms, but I was way off. We sent Nabeel to see what they're up to.
Oh, hey, I'm just taking a little elevator ride. This one goes a mile deep into the Earth to study some of the most elusive particles in the universe. It's actually going to be a long ride, so I might as well introduce Dr. Erica Caden, a research scientist and physicist at SNOLAB.
When I was in 12th grade, I took physics, and we took an amusement park field trip where we had measuring tools on the rides to take data on how the rides work. We worked out the calculations on the bus ride home, and that was a lot of fun. Physics is applied math, which is applied logic, which tickles my brain.
Now what tickles Erica's brain is analyzing particles smaller than an atom. Today, I'm learning more about Erica's work and the special detector she uses in her research. Turns out that's almost as hard to find as the subject she studies.
We finally made it.
This is SNOLAB.
I gotta ask, we took an elevator down a mile, we walked almost another mile. Why did we do all that?
We're looking for neutrinos.
What is a neutrino?
A neutrino is a very tiny subatomic particle that comes from all of the interesting reactions in space. It is basic physics. It is learning the tiniest building blocks of what we're all made of, what our universe is made of.
So they're naturally occurring particles in space, and they're all around us.
They're all around us. 60 billion neutrinos from the sun go through your thumbnail every second.
What? Get them out. That's cool, though.
Yeah.
Why are we underground? Are neutrinos better here for some reason?
So neutrinos produce teeny tiny amounts of light whenever they interact in our detector.
Erica explains that because other matter, like cosmic rays and background radiation, also create light picked up by their detector, the lab needs to be deep beneath the surface of the planet. Down here, those other particles are mostly blocked by the Earth, but neutrinos are able to pass through.
So the Earth gets rid of a lot of the distractions that allow us to more accurately study neutrinos.
Exactly, yes.
So why do you study these particles?
Well, we study neutrinos because we want to understand more about the world around us. I study neutrinos because I think they're the most interesting particle. We can understand how the sun is burning, we can understand how a supernova explodes, and we can understand the composition of the Earth by measuring its neutrinos. We can help understand why the Earth is so warm.
So what I'm gathering is there's a lot to be learned from neutrinos.
Neutrinos are the best.
One of the best ways to find them is by using a highly specialized detector, like the one Erica works with at SNOLAB, called SNOPlus. It's a giant acrylic sphere that measures 12 meters across, is filled with liquid, and is monitored by photosensors.
So this is one of the photosensors that we have in SNOPlus. There are about 9,000 of them all around the detector in a sphere shape.
Whoa, 9,000?
9,000. They are very, very sensitive. They can see a single photon, which is a particle of light, a single one. So any light that is produced inside the detector would be observed by these photosensors.
Talk to me about this liquid. What's going on there?
So the liquid inside the central volume of the detector is a special mineral oil with extra chemistry added to it to produce enough light so that we can really understand what is happening inside the reaction.
And what's happening inside is whenever a neutrino enters the detector, it interacts with the liquid scintillator, or liquid that makes light, and produces a photon. Each time the sensors detect a photon, it gets recorded as an event. But because many things produce light inside the detector, even with all the effort the lab goes through to ensure a clean environment, more than 3,000 events are registered per second. Neutrinos make up only 3 of those per day.
I get it. I understand. You're playing hard to get for the neutrinos.
Neutrinos are playing hard to get. Neutrinos are so difficult to get to interact. So we see 60 billion from the sun through our thumbnail every second. But only 3 interact in our detector in a day?
Really good point. You're right. Maybe they're the ones that are playing hard to get.
They're worth it.
And so is their data, which will be processed by computers and later analyzed, giving Erica and her team greater knowledge about this tiny particle, including ideas for the future.
One of my favorite things about neutrinos is that the technology we use in this field can be applied to many, many, many other areas. We can then take our knowledge for how to build our detectors, how to build gas handling systems, and then make devices like ventilators. We can use some of the different technologies that we have for other photosensors and apply them to forest fire detection. Who knows what applications we have for the technology that we haven't even thought of yet.
If you're watching this, you must have really liked the video. Make sure you follow and subscribe, and check out these other videos that are even better. No, really. I've seen this one over 100 times.